For decades, astronomers have felt like cosmic accountants who couldn't balance their books. They had a very good idea of how much normal matter should exist in the universe. This is called baryonic matter, and it's made of the familiar protons and neutrons we learned about in school. Based on calculations from the Big Bang, this matter should only make up about 5% of the total universe. But when scientists looked out into space and counted everything they could see, they came up short. About half of the expected baryonic matter was simply gone, earning it the nickname, the missing matter. This wasn't a small rounding error, it was a gigantic hole in our understanding of the cosmos. Imagine trying to build a puzzle, but half the pieces are missing. You can see the edges and a few key parts, but the full picture remains a mystery. Scientists knew this matter had to be somewhere, but it was too faint, too diffuse, and too spread out to be detected by traditional telescopes. It was a cosmic ghost, hiding in plain sight. This missing baryons problem has been one of the most persistent puzzles in modern cosmology, leaving a significant gap in our inventory of the universe and challenging our models of how structures like galaxies form and evolve over billions of years. Finding this matter was more than just an accounting exercise. It was a crucial test of our fundamental theories about the universe's origin and evolution. If the matter truly wasn't there, it would mean our understanding of the Big Bang was flawed. But if it was there, where was it hiding? The leading theories suggested it existed in a vast, hot, and incredibly thin web of gas stretching between galaxies, known as the intergalactic medium, or IGM. This cosmic web would be the scaffolding upon which the universe is built, but proving its existence and measuring its contents felt nearly impossible. We needed a new tool, a new way of seeing the invisible. The search for this elusive matter has pushed the boundaries of astronomy, inspiring the development of more powerful instruments and clever new techniques. Scientists have poured immense effort into scanning the skies, hoping to catch the faintest whispers of this hidden material. The mystery wasn't just about finding lost atoms, it was about confirming our entire cosmic story. It's a story that begins with a hot, dense state nearly 14 billion years ago and unfolds into the magnificent galaxy-filled universe we see today. Without accounting for all the ingredients, our cosmic recipe would remain incomplete, leaving us to wonder if we had misunderstood the very nature of our existence. The breakthrough came from an unlikely and mysterious source: fast radio bursts, or FRBs. These are incredibly powerful yet mind-bogglingly brief flashes of radio waves that erupt from deep space. Lasting for just a few milliseconds, a single FRB can release as much energy as our sun does in an entire day. Their exact origin is still one of astronomy's biggest puzzles, but scientists have realized these cosmic flickers are the perfect tool for illuminating the unseen. They act like powerful flashlights, shining a beam of light through the vast dark voids between galaxies. By studying how that light travels, we can learn about the material it passes through on its journey to Earth. Think of it like driving through a thick fog at night. The fog itself is hard to see, but when a car on the other side flashes its high beams, you can instantly tell how dense the fog is by how the light scatters and dims. FRBs work in a similar way. As their radio waves travel across millions or even billions of light years, they pass through the tenuous gas of the intergalactic medium. This gas, though nearly invisible, has a subtle effect on the light. It slightly slows down the radio waves, with lower frequency waves being delayed more than higher frequency ones. By precisely measuring this tiny delay, astronomers can effectively weigh the invisible fog. As Liam Connor, an astronomer at Harvard, beautifully puts it, the FRBs shine through the fog of the intergalactic medium, and by precisely measuring how the light slows down, we can weigh that fog, even when it's too faint to see. This ingenious method transforms FRBs from a cosmic curiosity into a powerful scientific instrument. Each detected burst provides a core sample of the universe, giving us a direct measurement of all the baryonic matter along its line of sight. By collecting data from dozens of these bursts, originating from different directions and distances, scientists can begin to build a comprehensive map of the universe's hidden material structure. A recent study published in Nature Astronomy on June 16, 2025, harnessed this technique to its fullest potential. A team of researchers analyzed 69 different FRBs, each one a golden ticket for their cosmic census. These signals provided the backlight needed to see the shadow of all the baryons, as Caltech's Vikram Ravi described it. It's an incredibly elegant solution to a long-standing problem. Instead of trying to see the unseeable, we are watching how the unseeable affects something we can see. This shift in perspective has unlocked a whole new way of exploring the universe, turning a deep mystery into a source of profound discovery. With their cosmic flashlights in hand, the team of scientists was finally able to pinpoint where all the normal matter in the universe has been hiding. The results were astonishing and confirmed what many cosmologists had long suspected. The overwhelming majority of the universe's baryonic matter is not locked up in the bright, shiny objects we typically associate with space. Instead, a staggering 76% of it exists as hot, diffuse gas in the intergalactic medium, the vast, empty-looking spaces between galaxies. This cosmic web, once purely theoretical, has now been observationally confirmed and weighed, proving it is the largest reservoir of normal matter in the universe. The study also revealed the location of the next largest chunk of matter. About 15% of all baryons reside in what are known as galactic halos. These are massive spherical clouds of hot gas that envelop entire galaxies, including our own Milky Way. Think of them as a galaxy's atmosphere, extending far beyond its visible stars and spiral arms. For years, these halos were incredibly difficult to study, but the FRB data has now made it possible to measure their mass and extent. This discovery helps us better understand how galaxies feed on surrounding gas to form new stars, and how they interact with their cosmic environment over billions of years. So where does that leave the matter we can actually see? The findings show that all the stars, planets, asteroids, and cold gas clouds within galaxies, everything that we have traditionally been able to observe, account for only a tiny fraction of the universe's normal matter. All the glittering stars and all the galaxies combined make up a surprisingly small percentage of the cosmic budget. This is a humbling realization. It tells us that the universe we see with our eyes is just the tip of the iceberg, the glowing embers on a much larger, mostly invisible cosmic structure. We live on a small island of visible matter in a vast ocean of transparent gas. For the first time, the baryon budget is closed. As Nicholas Tejos, an astronomer not involved in the study, stated, "Thanks to FRBs, we have now been able to close this baryon budget. This is a monumental achievement for cosmology. It resolves the decades-old missing baryons problem and validates our models of the early universe." The numbers finally add up. The discovery provides a solid observational foundation for our understanding of cosmic structure formation, confirming that galaxies are not isolated islands, but are connected by immense filaments of matter that have guided their growth and evolution since the dawn of time. Solving the missing matter mystery does more than just balance the cosmic books. It fundamentally redraws our map of the universe and opens exciting new avenues for research. We now have confirmation that the cosmos is built upon a vast underlying skeleton of baryonic matter, the cosmic web. This knowledge will allow astrophysicists to refine their simulations of how galaxies form and cluster together, leading to a much more accurate picture of cosmic evolution. Understanding the distribution and temperature of this intergalactic gas is key to piecing together the complete life cycle of galaxies, from their fiery births to their eventual quiet fading. The success of using FRBs as cosmic probes is just the beginning. The research team is already looking ahead to the next generation of radio telescopes, like the upcoming Deep Synoptic Array 2000. This powerful network of 2,000 radio dishes will be able to scan the sky with unprecedented sensitivity, with plans to detect up to 10,000 new FRBs every year. With such a massive dataset, scientists will be able to create a highly detailed, three-dimensional map of the baryonic matter throughout the universe. This will be like upgrading from a blurry sketch to a high-definition photograph, revealing the intricate details of the cosmic web in stunning clarity. Of course, this breakthrough also highlights the even bigger mysteries that remain: dark matter and dark energy. Remember, all this normal baryonic matter makes up only 5% of the universe. The other 95% is composed of dark matter, 27%, the invisible gravitational glue holding galaxies together, and dark energy, 68%, the mysterious force driving the accelerated expansion of the universe. While we have now found all the normal matter, we are still very much in the dark about the nature of these other components. The techniques used to find the missing baryons could potentially offer new clues in the hunt for these even more elusive cosmic secrets. This incredible discovery invites us to look up at the night sky with a new sense of wonder. What do you think this new, more complete picture of the universe means for humanity? Now that we have found the missing normal matter, Do you believe we are on the cusp of solving the greater puzzles of dark matter and dark energy as well? The universe has revealed one of its long-held secrets, but in doing so, it has reminded us of how much more there is to explore. We'd love to hear your thoughts on this amazing breakthrough in the comments below. Thank you for joining us on this journey of discovery.